right. Hey everyone. Sorry for the shadows on the page. I don't know how that would work. Let's see. I think that helps a little bit. Okay. So today what I'd like to do is actually work through some problems from chapter 3.3. All right, I'm going to work through some problems from chapter 3.3 on our homework. Because I noticed when I was grading the exams that there were some questions about how to do some of the displacement and distance travel. Okay, so the first question that we were given, we're actually given the velocity. So we're given the velocity. Our velocity is a vector function. So I have 2 pi t, 3 cosine of 2 pi t, and 4t. And we're going from time. Our time is going from 0 to 2. Okay, so we want to be able to calculate things. So the first thing that they're asking us for is to calculate the displacement. Okay, well, we're given the velocity. Okay, so I can actually, I don't have to do anything extra like on the exam. I don't have to do anything extra in order to calculate the displacement. So to calculate the displacement, I just have to integrate my velocity. It's a function of time from the time t equals 0 to time t equals 2. That's what they gave us to begin with. So I'm going to write it out. Okay, so because velocity is a vector function, I've got the x component, the y component, and the z component. And I want to integrate this vector. So how we do that is this. I'm going to integrate each vector as though it were an individual, make this a gt, as though it were each an individual function itself. So 0 to 2, so here's my x, 0 to 2, 3 sine of 2 pi t dt, 0 to 2, 3 cosine of 2 pi t dt. This is our z component, 0 to 2, 4t dt. And I'm going to close it out. So my answer for displacement is also going to be a vector. Okay, so that I have each x, y, and z component for my displacement. Okay, so now I'm going to use my trig rules to help me integrate this. So I'm going for 3. The 3 is going to pass through as a constant term. The 2 pi t, you can think about this as a u substitution, okay, with our du being 2 pi dt. Okay, I'm going to divide by 2 pi, so that if I divide by 2 pi, that comes out. So I'm going to get 3 all over 2 pi times minus the cosine of 2 pi t, and I'm going to evaluate that from 0 to 2. That's my x component. Remember, the integral of sine is minus the cosine. My y component, 3, because I've got the constant, I've got the 2 pi that I need to take into account. When I integrate cosine, I get sine of 2 pi t, and I'm going to evaluate that from 0 to 2. And then 4t is our power rule, so it becomes 4 times t squared over 2, which is just 2t squared. I'm going to evaluate that from 0 to 2. Okay, so plugging these things in, I get minus 3 over 2 pi times, right, I factored out the negative. I'm going to get cosine of 2 pi times 2 minus cosine of 2 pi times 0. Okay, so the cosine of 4 pi, right, 2 pi, 4 pi, they're the same thing as 0. Cosine of 0 is 1. Cosine of 4 pi is equal to 1. So 1 minus 1 gives me a 0 in my x component. Okay, now I'm going to evaluate my y component, 3 over 2 pi. This is going to be sine of 2 pi times 2 minus the sine of 2 pi times 0. Okay, so let's remember the sine of 2 pi, or since, I'm sorry, the sine of 4 pi, right? 4 pi is the same thing as 2 pi, which is the same thing as 0. Sine of 0 is 0, sine of 0 is 0. So this whole thing becomes 0 minus 0 times 3 over 2 pi is 0. My z component, this is 2 times 2 squared minus 2 times 0. It's 2 times 2. 2 times 4 is 8. So my total displacement, which we'll call here, this is our displacement. I'm sorry, I realize you can see that. Our total displacement here is the vector component, right? We integrated our velocity. We were given the velocity, so we integrated our velocity from 0 to 2. That was the time window that they gave us. Okay, and I did that. I evaluated each term. My displacement is a vector. Okay, now on this homework, they didn't ask us to come up with the total distance traveled, but we're going to do it anyway, just so we can see. Okay, so the total distance traveled is, we're going to assume it's the same time window we're making up this problem here, which means we're going to take the magnitude of the velocity first, and then we're going to integrate it. Often on these questions, we ask you just to set up the integral. Okay, so we're going to just set up the integral here. So I'm going to go from 0 to 2. My magnitude of my velocity, and now remember the velocity function that they gave to us from before. I'll write it down here. 3 sine of 2 pi t, 3 cosine of 2 pi t times 4 and 4 times t. So we have our x, our y, and our z component. So the magnitude says I'm going to take the square root of the sum of the squares. So 3 sine of 2 pi t squared plus 3 cosine of 2 pi t squared plus 4t squared dt. This is my x component squared plus my y component squared plus my z component squared. This is x, y, and z of my velocity. I was given the velocity, so that's what I'm using here. Okay, I square each component, add them all up. It's not a vector anymore. Our total distance traveled is going to be a scalar. It's just going to be a number, which I'm not going to integrate. We often just tell you just to set up the integral like this, so I'm going to leave it like that. On this homework problem, they didn't ask us to do it, but we're working through it just so that you can see. Okay, so that's question number 1, 3.3. Let's talk about question number 3. This is really similar to the one that we just did. Again, they gave us the velocity, which is 3 plus 4t, 5 minus 7t, and 11t, and we're going to go from minus 3 to 7 in terms of time, in terms of our time window. Okay, so again, what I'm going to do is I'm going to set up my integral. Okay, which means I'm going to integrate minus 3 to 7, my whole velocity, so it's 3 plus 4t, 5 minus 7t, 11t. Notice how I have commas for my x, y, and z components, dt. When I want to integrate a vector, I'm going to integrate each piece, 3 plus 4t dt, comma, integral from minus 3 to 7, minus 5 minus 7t dt, comma, integral from minus 3 to 7 of 11t dt. And I'm going to end. I've got a vector, my x component, my y component, and my z component. So now these are just power rules I'm going to work my way through. So what we're going to get is 3t plus 2t squared. I'm going to evaluate that from minus 3 to 7. This result is going to be our displacement, right, which is a vector. Okay, my y component is going to be 5t minus, oops, I'm sorry, this is positive, 5t minus 7 halves t squared, and I'm going to evaluate that from minus 3 to 7. I'm going to get 11 over 2 t squared evaluated from minus 3 to 7. Okay, so then I just plug in things, right? So I'm going to get 119 minus 9 minus 136.5 plus 36.5, and then 220. And I add everything up, I get 110 minus 90 and 220. And this is equal to my displacement. It's a vector. I've got an x, y, and a z component. Okay, now again, they didn't ask us to do total distance travel, but we'll do it just so that we can see what it looks like. Okay, so total distance travel, remember, we're going to go from time t0 to t1. I'm going to take the, looks like the absolute value, but it's a magnitude, because velocity is our vector. Okay, so what that means is I'm going to take this, I'm going to go from minus 3 to 7, and I'm going to take the magnitude of 3 plus 4t, that's our x component, 5 minus 7t, that's our y component, 11t, that's our z component, dt. So I'm going to take each term, my x, y, and z, and I'm going to square them, sum them up, and then take the square root. That'll be my total distance traveled. So I got this big square root, my x component, 3 plus 4t, quantity squared, plus my y component, 5 minus 7t, quantity squared, plus 11t squared. I'm adding all these up, taking the square root, and then I integrate. We often, like I said, we often just ask you to set up the integral, so I'm not going to worry about, normally on this kind of a problem, I would FOIL things out, I'd combine all like terms, I try to find a way to factor it, so that I could then take the square root and then work it through or do some kind of U substitution. But we're just going to leave it as the integral. So that's question 3. Question 19 is a lot like what we had on our exam. So question 19 is, we're given the position, the function for the position. Okay, we want to be able to calculate the total distance traveled. We're also going to do displacement too. We weren't asked for it, but we're going to calculate it. So our position function, P of t, is sine of 3t, cosine of 3t, 2t to the 3/2. Okay, and we're going to go from t equals 0 to t equals pi. Okay, that's our time window that we're working with. All right, so this is position, but I need velocity. Remember, our total distance traveled, let's just write it down so we can keep ourselves honest. Total distance traveled is going to be from time t0 to time t1. I'm going to take the magnitude of my velocity. Okay, I need the velocity, but I was given position. So we have to remember how our velocity and position related. So velocity is equal to the derivative of position. Well, if that's the case, so I need to take the derivative, sine of 3t, cosine of 3t, 2t to the 3/2, and I need to take that derivative. Okay, well, I'm going to take the derivative of a vector, just like we did with integrals. I'm going to take the derivative of each individual portion, and I'm going to leave it in its vector spot. So the sine, when I take the derivative of the sine, I get the cosine, and I've got this 3 hanging out here, so I've got to go 3 cosine of 3t. Okay. When I take the derivative of the cosine, I get minus the sine. I have a 3, so I need minus 3 sine of 3t. And then this is just our power rule, right? So 2t to the 3/2, and I take that derivative. What I'm going to get is 2 times 3 over 2, t to the 3/2 minus 1, right? So this becomes 3, t, so this is 2 over 2. So 3 over 2 minus 2 over 2 gives us 3t to the 1/2. Okay, so that becomes our z component. This is our velocity. We had to take the derivative of our position function in order to get the velocity. This is what I'm going to be working with now in this problem. Okay, unlike the previous 2 problems where I was given the velocity and I could just kind of work from there, here I actually have to do some stuff to actually get the velocity from the position function. Okay, so first part, we'll do displacement first. I know they didn't ask for that, but let's do it first. So the displacement, remember, we're going to go from 0 to pi, and we're going to integrate our velocity. Okay, so when I go to do that, I'm going to go from 0 to pi, and I'm going to integrate 3 cosine of 3t minus 3 sine of 3t, 3t to the 1/2. Okay, so when I go to integrate that, I'm going to integrate each piece of 0 to pi, 3 cosine of 3t minus 3, oops, 0 to pi, minus 3 sine of 3t, 0 to pi, 3t to the 1/2. And each of these has a dt in there. Okay, so when I go to integrate, let's think about this. When I go to integrate the cosine, right, if I take the derivative of the cosine, I get a negative sign, but if I integrate the cosine, I have to think about what is this? This is going to be the derivative of something. So I'm going to get this 3 passes through, right, and I'm going to get sine, I'm going to get sine, okay, of 3t, but I've got this u, it's just like u equals 3t, my du equals 3 dt, I have to divide by 3, so my du over 3, so I have to divide out a 3, okay, so I get 3 over 3 sine of 3t, which is really just equal to sine of 3t. I'm going to evaluate that from 0 to pi. Oh, look at that, it looks similar to what we have here, right? It should. Okay, so now we're going to do this here as well. Okay, so when I integrate the sine, right, I can take out the minus 3, so the minus 3 comes out on the other side. So I've got minus 3. Remember this 3t here, I'm going to divide by 3. When I integrate the sine, I get a minus cosine of 3t, minus minus. So it's going to give me cosine of 3t evaluated from 0 to pi. Same thing for here. Okay, when I go to integrate this, I've got the power rule. Okay, so the 3t to the 1/2 dt, the 3 comes out on the outside. So 3 times, think about what's happening, t to the 1/2 plus 1 all over 1/2 plus 1. Okay, So this is 1/2 plus 1, so this is 3 times t to the 3/2 all over 3/2. Well, this is the same thing as 2 divided by 3. So I'm going to get 2t to the 3/2, which is what we started off with. So we're knowing we're doing the right thing. 2t to the 3/2. And we're going to evaluate that from 0 to pi. You have to do this because what if I had, like on our exam, sine of 3t plus 1? Okay, when I take the derivative, the plus 1 goes away, and I integrate it. I don't have it because now look, I'm evaluating that 0 to pi. Okay, so I have a different constant term that I'm working with. So let's go ahead and plug this in. So sine of 3 pi minus the sine of 0, cosine of 3 pi minus the cosine of 0, because 3 times 0 is 0, 2 pi to the 3/2 minus 2 times 0. Okay, and this is our displacement function. So 3 times pi, so sine of 0 is equal to 0. Sine of 1 times pi is going to equal 0. 3 times pi, it's an odd number, that's also going to be 0. So this thing here is 0. 3 times pi, so cosine of 0 is equal to positive 1. Cosine of 3 times pi is going to equal negative 1. Okay, so minus 1 gives us a minus 2. This part here is 0. So this is 2 times pi to the 3/2. So I'm just going to leave it as 2 times pi to the 3/2. And that's my displacement. Oh, sorry, you can't see that. Displacement from time t equals 0 to time t equals 5. They didn't ask us for that, but I wanted to show you how that looks different. Okay, so let's do our total distance traveled now. This is what they actually asked us for. This one has some algebra, but we'll work it through. So the total distance traveled is going from 0 to pi. We're taking the magnitude of our velocity, which is the velocity function that we derived before. So when I do that, I'm going to go from 0 to pi. I have the square root. I take my x component, 3 cosine of 3t. I square it. Plus minus 3 sine of 3t. This is our y component squared. Plus 3t to the 1/2 squared. I add all those terms up, I square root it. I'm going to integrate that from 0 to pi as a function of dt, as a function of t. All right, so let's go ahead and do this. So 0 to pi, we've got our square root. So this is 9 cosine squared of 3t. Watch out, this 3t doesn't get squared. It's the coefficient on the outside that does. It's the function cosine squared. Okay, the function gets squared. Plus 9, right, that's this thing here, sine of 3t, sine squared of 3t, plus, right, I'm going to square all this stuff. This is 9 times t dt. Now I can factor out a 9. When I factor out the 9, I take the square root, I'm going to get, I'll bring the 3 cosine squared of 3t plus sine squared of 3t plus t dt. Now remember, cosine squared plus sine squared is a Pythagorean identity. That's equal to 1. So we're looking at 3, 0 to pi, the square root of 1 plus t dt. Okay, which means I can actually do u substitution when I go to integrate that. So when I go to integrate that and I actually bring it through, what I'm going to get is 3 times 1 plus t to the 3/2 divided by 3/2, right? And we're going to evaluate that from 0 to pi, which dividing by 3/2 means multiplying by 2/3. And I'm going to get 2 times 1 plus t to the 3/2, and I evaluate that from 0 to pi. And I plug in what I have, and I'm going to get 2 times minus 1 plus 1 plus pi to the 3/2. Okay, this is my total distance traveled. It required some algebra for me to do. But I had to remember that there was a Pythagorean identity. The toughest part about all of this was at the beginning, we were given the position function. We had to differentiate that to get our velocity. This is the velocity that we're working with throughout the rest of the problem.